What just happened? Did we just experience an earthquake? But why does this happen, and what exactly is an earthquake? Earthquakes are caused by the release of energy that generate waves which travel in all directions, causing the shaking of Earth's surface. What exactly is this energy? What waves? What's shaking of Earth's surface? This is so complicated. Well, calm down. Let me explain everything in a simple and detailed manner. Earth is not just one piece. It is made up of jigsaw puzzles of around 19 to 20 pieces, which are called as tectonic plates. These plates are placed on a hot, partially molten layer of Earth's mantle. This is the reason why these pieces are continuously moving. They are moving as you are watching this video. These plates move around 1 to 10 cm each year. But don't worry, not all these movements can be felt by us. Sometimes these movements are extremely strong and can be felt like a lot of vibrations under your feet. Or it can also destroy an entire city. That's called an earthquake. The earthquakes occurs in the lithosphere region of the earth. An earthquake generates underneath the earth and this releases the energy across. The point at which the earthquake occurs under the earth is called hypocenter, and the exact place above it at the surface of the earth is called epicenter. The most horrifying earthquake recorded till date was of magnitude 9.5 out of 10. This happened in Valdivia in southern Chile in 1960. Another one that happened in Japan in Tohoku region was of magnitude of 9.0, which happened on March 11, 2011. This earthquake caused massive and enormous damage and destruction and took nearly 16,000 people's life with him. Geologists use a device that can sense the waves created by the movement of the tectonic plates. These waves are known as seismic waves, and the device is called as seismograph. The earthquake events are scaled according to magnitude of the shock and are known as Richter scale. This magnitude relates to energy released during the earthquake. Magnitude is expressed in absolute number 0 to 10, where 0 is lowest, where people feel nothing, and 10 being the highest that can create severe destruction and loss of life over a large. In order to know more about earthquake, let's jump to the simulator. We can see on the screen is the inner core of the earth, and then we have outer core, mantle and crust. The inner core, as the name suggests, is the innermost layer or the central layer of Earth. It is like a solid spherical ball in nature with a radius of 1250 kilometers. The temperature of Earth's core ranges between 4500 to 5500 degrees Celsius, facing a pressure of 300 to 360 gigapascals. Next is outer core. It is of about 2200 kilometer thickness and has a temperature similar to inner core, that is of 4500 to 5500 degrees Celsius. Then we have the mantle layer, which is the semi-solid state of about 2900 kilometer thickness. This layer makes around 84% of Earth's total volume. And the last layer is the crust, which is like an apple's skin when compared to other layers. Runs from 0 to 70 kilometers in thickness, which is specifically 8 kilometers under sea to 32 kilometers under continents, and this is only 1% of the Earth's total mass. Now we can see that there's a grayish white dot. Let's click on that. We can see a small town when we see this in the street view, and then When we click on Layers view, we can see Earth's layer. The grayish in color is called as crust, and the one in reddish color is called as mantle. On the left-hand corner side, we can see we have a small box that says earthquake magnitude on Richter scale with 3 buttons that shows the magnitude of the earthquake. If the intensity is between 0 to 2, it can be barely sensed. When the intensity is more than 2 and less than 4, we can feel minor vibrations and sense it a little. From 4 to 4.9, it is considered as small or a light earthquake. Range from 5 to 5.9 are considered moderate earthquakes, and from the range 6 to 6.9 are considered as strong earthquakes. In some time, we will see how much damage these magnitudes can do. And anything above 7 is considered as major earthquakes which can destroy cities and continents. These readings are recorded on a seismograph. Now, let's hit the 4 to 4.9 magnitude to see how this earthquake happens. We can see the earthquake starts from a point called a hypocenter inside the earth. During an earthquake, 2 types of waves are formed. One is called body waves and the other are called as surface waves. Let's see what are called as body waves. Body waves are the waves that move through the interior of the earth and through the body of the earth, and hence the name. When these body waves move, these waves come across the surface rocks and generate the surface waves. Let's see in detail about these body waves and surface waves. From this point, that is hypocenter, waves are released. These waves are called primary waves or P waves. Now, what are these P waves? P waves are seismic waves that shakes the ground back and forth in the same direction and the opposite direction, as the direction of the wave is moving, which is similar to the movement of the sound waves. This is how a P wave looks like. These P waves are the first to be recorded on a seismograph. Now, after a fraction of a second, when these P waves hit the rocks closer to the surface, gives rise to a new set of waves, the S waves, or called as secondary waves. These waves are towards the earth crust, and these are tremors and vibrations that we feel. S waves are the wave motion in a solid medium where the medium moves perpendicular to the direction of the wave. After the P wave, these S waves are recorded on a seismograph. Now these S waves hits the surface and starts the earthquake. The point at which the earthquake originates on the surface is called an epicenter. After the P and S waves comes the surface waves, which are the most destructive waves as they cause the movement or the displacement of the rocks, which leads to falling of structures and causing harm to life. Let's once again see the formation of P and S waves. We can see that an earthquake of this magnitude, that is between 4 to 4.9, causes the damage to nearby small houses, but the buildings are okay. Let's see what happens when the magnitude is between 5 to 5.9. Let's reset and then hit the button. Whoa, that's quite some damage. The small houses are shattered and the buildings also have cracks. We can also see that the road is also cracked now. One more thing to notice is that the higher the magnitude, the closer the hypocenter is to the epicenter. Notice this when we move to 6 to 6.9 magnitude. The damage is enormous. Buildings are almost broken, roads are cracked, and small houses are collapsed. earthquakes can really be extremely damaging natural calamity. If this is the case when magnitude is limited to 7, imagine how 9 and 9.5 might even look. Since these are quite commonly occurring magnitudes, we have studied them in this simulation. It is extremely difficult to predict an earthquake based on a seismograph, which is also known as seismometer. But even our smartphones can now detect these seismic waves, and scientists can use this data to predict earthquake and warn people. NASA can use this information in the QuakeSim software, which can use this data to generate more efficient information. Recent studies showed that before an earthquake, nearby regions record very high concentrations of radioactive pair, radon and thoron. This happens because right before the earthquake, these gases are released on the surface from small cracks, and if we can detect these gases, we can predict a quake at least 7 days in advance. Well, here are some tips that can save you in case of an earthquake. Till then, keep yourself safe and see you in the next session. Well, I hope you have enjoyed this session. This session is based on an interactive 3D simulation called Scholar, developed by Escavel. Visit www.escavel.in to request the download of the software application to try this out yourselves. If you have enjoyed this video, hit the like button. If you have any queries, comment down, and yes, don't forget to hit the bell icon and never miss another update from Let's Tute. Keep watching, keep learning, and follow your curiosity. Thank you.